the ratio test. This looks kind of similar to the limit comparison theorem, but it's totally different. That was this. Remember that? Recall that the other one was this. AN. You're comparing with a different one, not the same one. One term afterwards, but a different one. So this is a limit comparison. Don't confuse it with this one. And this also has an absolute value around it. Right? So we have AN plus 1. This is a term that comes right after AN. Right? So if you take their limit, so basically you have a sequence. You're always taking the term right beside each other. And you're taking that ratio to the limit. If that happens to be a number that's less than 1, then it's absolutely convergent. If that happens to be bigger than 1, it's going to be either bigger than 1 or less than 1 because it's absolute value. It's not going to be negative. Then we say the series is divergent. If it happens to be exactly 1, we don't know what's going on. Okay, we're not sure. Okay, this test doesn't tell you anything about it. Okay, so there is a proof for this too, but let's do some examples and we'll do a proof separately. Okay, let's do some examples. Okay, so here it is. This is my AN. Then my AN plus 1 is going to be this, right? Now look, this time it's important what you put on top. You have to put this on top. Okay? And we're going to take an absolute value of that. Okay, so we have n plus 1 cubed 3 n plus 1. Instead of dividing, I'm going to times, because it's a fraction, I'm going to times it by the reciprocal. Okay? So we get, let's put this expression and this expression together because they're very similar looking. And let's put these two together. And for obvious reasons, I'm going to separate the plus 1 as times by 3 because I can cancel that out, right? Now, what's going to happen to this? What's the limit of this divided by this?
Ends approaching infinity, right?
Yeah, ends approaching infinity. It's more obvious if we do this. Can we do that? Do they have the same exponent? Right. You can separate that as 1 over 1 plus n. So this is clearly approaching 0 as n approaches to infinity. So this is going to be 1 cubed times by 1 over 3. So it's 1 over 3 as n approaches to infinity, right? Therefore, it's absolutely convergent by ratio test. Okay, make sense?